2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome back to our show, Mathline. You have found the right place. Some of you found it on PBS, some of you finding it on YouTube, some of you may have found it on Passport. Well, we're glad you tuned in. I'm Ernie Roberts, and I'm your host for today's session. Now, what we're doing is a little bit different here as we take these specialized segments. It's not a call-in day. As many of you know, our show is all about calling in. We give you good answers and help you work through problems. Well, this time we're going to present to you, all right? We're going to pick up some topics, and we're doing what we call test prep right now. That's to get you ready for, end-of-course testing, ACTs, SATs, PSATs, all those great college entrance exams, even other good things. But what we want you to understand is, hey, it's here to help you. We've got some good hints. We've got some good sample problems. And whew, I tell you what, let's see what we got to offer today. I'm already worn out, ready to think about it. Let's see what we've got. Meeting, the Son of Blockbuster. Some of you going, what? What's the Son of Blockbuster? Well, it's got a little bit of blockbuster in him, I guess, there, you know. So a little running joke there. Let's go back to what is blockbuster in my mind, all right? First of all, I like to sometimes think that blockbuster means a very, very big deal, and it is. So we've called it a blockbuster theorem from my standpoint here, which is the 180 degrees in a triangle. So let's go ahead and look at this. It's also known as, yes, many of you call this Triangle Sum Theorems. Some of you say, it's 180 degrees in a triangle of the interior angle measures, all right? When we talk about degrees, I see a lot of times students put 180 and they use the perimeter. That's not correct. It's the angle measures. It's these inside lovely angles here that are going to add up to 180. So in putting it in nice simple terms here, how about it? Measure of A, by the way, that's what that little m stands for. Sometimes we don't see that, but it is the measure of A plus the measure of angle B plus, yeah, you got it, the measure of angle C. They'll always add up to 180 degrees. Don't care what kind of shaped triangle we've got. Don't care if it's isosceles, if it's equilateral, if it's scalene, if it's acute, obtuse, right. They're always going to add up to 180 degrees. That is one of the beauties of the triangle. And by the way, why is that important? Why do I call it blockbuster? Because so much of geometry hinges on this little guy right here, all right? Once it's established, and that's what we've got, we're going to pick up the Son of Blockbuster, which is a pretty big deal also in its own right as another theorem today, all right? But let's go back and again, let's review the Triangle Sum Theorem. Blockbuster. Let's see what we've got here. Let's take a look at an example problem and throw in a few odds and ends. The odds that I threw in here was the parallel lines, which make things kind of nice. Folks, when they give you something like this in a test problem on the SAT, ACT, your PSAT, your end-of-course state tests, those kind of things, take it and run because it means there's some good stuff there that's going to help you if you will just let it. Now, we've got a lot of angles in this picture. You know, Ernie? Yeah, Ernie will say probably one of those would be what we're looking for. But we're going to look at all of them because I like the problem. And notice we've got some numbers here. So get your chance to write these down. By the way, get your pencil and paper at home. And let's see what we've got going on. You can draw the picture, sketch it out. A lot of this you may be able to do mentally. But we're going to try to figure out what the measure of angle 1, measure angle 2, measure angle 3. Oh, wow, we're at measure angle 4. 5 and 6 come out to be. Now this doesn't take algebra. This is mostly going to be kind of arithmetic. And remember we said that fact, blockbuster, 180 degrees. When those three angle measures are added up inside a triangle, you get 180 degrees. So let's play it out here. I'm looking at angle 1 and I don't think it's going to go very far right now. I need a little help because I don't know the measure of angle 2. I don't know the measure of angle 4 or 3. Oh, but I do know something. Some of you are saying, Ernie, don't go too fast there. And I'm not going too fast. I just want us to start thinking about it. The question is, does angle 1 have another relationship besides the 180 degrees in the big yellow triangle? Well, you know, the big yellow triangle's got a 35. Man, if we knew one, we got two, don't we? So let's take a look. Parallel lines. Remember we talked about those parallel lines? A little nice hint here in this problem. You've got a 65 going right here. And if you look those are the parallel lines. This becomes a transversal. This horizontal line we've got going here becomes a transversal. And so what does that mean, Ernie? That means corresponding angles. Corresponding angles will match up congruently. And if you'll notice, 65 and 1 match up congruently. So let's go ahead and mark that and put a 65 right there, 65 degrees, and we'll put it right down here. And you say, well, that was pretty nice and pretty sweet, Ernie, because guess what? Now we can find angle 2 without any problem whatsoever. We'll add the 65 that we got here, so beautifully done, by corresponding angles. And by the way, that only works because those lines were parallel. Got to be careful. Now, in that case, once we know that we add 35 and 65, we get 100, which is really nice because you can subtract that off in your head. So here we go. 80 degrees. And we have a nice right, oh my goodness, we have a right answers here, right? Correct? Because you look at all three of these and they add up to 180 degrees. That's good news. So put our 80 right there. We'll keep it in mind there. That's our angle measure for angle 2. All right, now, spinning backwards here. We always love to spin backwards. Here we go. Let's look at this. Oh man, there's a couple ways we can go because we've got 65 and 55. You could pull down number 4 because what? Those three angles add up. They make a nice little straight angle together, 180 degrees. Their measures would add up to 180 degrees. So there's another. 180 is a big deal in geometry and math, isn't it? Now, let's go another point here. Parallels, zigs and zags, all right? And when they zig and zag like this, this becomes a transversal right there. You got it? And that means 55 and 3 are alternate interior angles. And guess what? If the lines are parallel, we got parallels going on here, they will be congruent, meaning they got the same measure. So we have angle 3 under our belt right now. There goes 55 right up there to the top. We'll put a 55 degrees right in there for angle 3. Now, angle 4. Angle 4, where did I put it? It's somewhere in there. I think I got a little carried away, folks. I put a 5 and a 6. I don't see a 5 and a 6. You can make your own up there and figure out what's going on, right? We might just do that. We'll add those to the picture. How about it? Okay, let's see here. Angle 4 is our last moment. Look what's going on here. We've got 65, 55, and angle 4 adding up to 180 inside the triangle. But look what else is going on. We've got 65, 55, and angle 4 again adding up to 180 off the straight angle. Beautiful problem, isn't it? Because we're going to get the same answer. It's going to satisfy either one of these. So piece it together in your mind real quick. How about it? What's 65 and 55? Boy, I hope I don't mess up at this point. Wouldn't be good, would it? I believe we're going to get 120 out of that, and we subtract that from 180. We're going to have 60 degrees left. And my friends, everything is all right. It's going to work out really nice. Now, you say, Ernie, what other angles? There are no other angles in the picture. But you know what? Maybe I could have done this. You always worry about when I say I could have done this. What if I had extended this little guy out just a wee bit? That way. Oh my goodness. Well, look what we have. We have an angle formed with the 65 there. We're making a linear pair. So I could ask that. Maybe that could be angle 5. How about it? And we know, well, what do we know? Well, we know that that's going to be, subtract from 180, we're going to have, looks like 115 degrees right there. Now that's interesting. If this is 60, and that's 55, and this was what, 115, there seems to be a little relationship going on there. And you know, I could play the same thing out this way. I could run a little bit right out through there. And it always helps if I use the protractor, doesn't it? Let's do it. Right there we go. And guess what? Slip that down just a tad. And we got another linear pair action going on here. And it looks like that's going to be about 145 degrees. Now I want you to notice again, how does that 145 relate to angle 1 and 2? All right. Now, you say, well, Ernie, why are you asking questions like that? Because this, my friends, is where we're going for today's topic, all right? So let's get ready to move it all over here, and we're going to take care of our friend, Son of Blockbuster, all right? You say, well, what is that about? What is Son of Blockbuster about? Well, have you had enough review for triangles? Let's do one more, all right? And we're going to see another connection here, and then we're going to talk about what is that kind of thing that we were drawing in there. Let's take a look at this little picture here. Got a lot of angles. This time I think we actually do have 5 angles. All right, so let's take a look at this baby. First of all, a lot of triangles in the picture. There's a big one, ABC. Everybody see that? There's one in the middle, BDE. I like BDE because I think I can figure out angle 2 because I see 180 degrees happening there. So this is a little angle 2 right there. We can figure that out. 1 and 4 over here in this little triangle, ADB. So what I want you to start seeing is sometimes we have more than one triangle. Actually, we have 6. 6, count them. We've got 3 little guys, all right, 1 big one, and we've got 2 that are basic, kind of look like they're overlapping, like ABE and CBD. So you've got a lot of opportunities to use 180 degrees in a triangle in this picture. And also you've got a chance to use some straight angle moments, linear pairs, supplementary angles. 4 and 70 will add up to 180. 65 and angle 5 will add up to 180 degrees. So lots of ways to work through this problem. So let's go through and see what we would do. And again, because there's so many tricks that we start learning, there may be more than one way to get through the problems. Just trust me on that. So let's see. Angle 1, 2, and 3. Here we go. And I said angle 4 and angle 5. And I'm going to create, I will think about it. Probably will put an angle 6 in there somewhere. All right. But for right now, let's play out the picture here. We have angle 1 needs a little more help. We need to figure out what angle 4 is before we can go to angle 1. But you know what? We can get angle 4. Like I said a minute ago, they're supplementary. Make a linear pair. So let's put 110 degrees right there. You know, a lot of times when you have a problem like this, whether you're at homework or whether you're doing out of the textbook or whether you're doing a ACT, SAT type prep question here, but just look for things that you know are going to work. You know those 2 angles add up to 180 degrees, correct? You got it? Nod with me? Of course you are. Now down here we've got this 180 adding up with angle 5. Well, goodness, well, we should get it if we add 65 and angle 5's measured together. So we need to subtract it. Hit the calculator if you need to. Do it in your head if you can. I believe we're going to get 115 out of that. And what's just happened is we have basically killed the problem, haven't we? We've done a great job with it. Because now we have these 2 angles, which will add up to, you got it, 180. That sounds like a good idea. And subtract. And I'm catching, what are y'all catching? 150 from 180? 30? I like 30. Angle 1 is 30 degrees. Now, let's kick along here. Inside this little guy right here, we got 70 and 65. And you're like, wow, okay, 70 and 65. 100 and what? 135. Subtract them out. I believe we're going to have 45 up there in that middle angle right there. That's angle 2, 45 degrees. And last but not least, what did we put here? We put, 115. That was a big old thing. And let's see where we're going to go with that. Well, we got 115. Didn't we say that for angle 5? That's what we said. Add 35 to that. Looks like are we already up to, are we back up to, wow. We're up to what? 150? So 30 degrees back there for angle here. Now, magic moment number whatever, all right? Remember I said there are a lot of triangles going on here. Let's pick out, first of all, this one, if we have 70, 65, and 45, do we add up to 180? We certainly do. So that triangle is happy. Very good, all right? Over here, we popped over, what was it? Yeah, 110 degrees, right? 110 degrees. And we added that 40, so we got 100, we got 180 on that one. My goodness, we've got 180 on this one, I believe, right? 115, 35. And what did we decide? 30, all right? Now, the big proof in the pudding. Let's take a look at the big triangle. Does it give us 180 degrees? Well, we got 40 and 35. I'm just curious. It's supposed to. Because remember, it doesn't matter what kind of triangle, what size it is, or whatever. The degree measures always add up to 180. So let's pick these 3 up. Right here they are. That looks like it's going to be 30. 30 is 60. 45, that's going to be 105 for that big angle. And look, 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 my friends, 180 degrees, 180 degrees. Now, I'm getting to the Son of Blockbuster today, which is all about the exterior angle relationship, all right? It's another AKA moment. And I want you to notice something here. This 70, how does it relate to angle 1 and 40? Well, angle 1 was 30, and there's 40, there's 70. You think about it. Think about it long, okay? How about this one, 65 over here? Angle 3 was 30, 35 there. Think about it. How do those relate? That's the names. That's going to be our point today when we look at our next piece. So let's talk about it. We're finally getting to that thing called an exterior angle of a triangle and also Son of Blockbuster. So let's see what we've got here. And it's also known as the exterior angle theorem, all right? Again, I like having fun with the Blockbuster family. There's so many things that Blockbuster pushes forward, all right? 180 degrees in a triangle. You got that. Everybody knows that, right? If you haven't by now, we'll say it 3 more times during the show and you'll have it down and take it to the bank. Now, what are we talking about here? The exterior angle of a triangle. I've drawn a picture of a triangle and I've got this little thing extending out right back here. My friends, this is the exterior angle, one of the exterior angles of this triangle. There are actually 6 of them, all right? You say, what? I don't see 6 angles. Well, I'm going to call this angle 1. And it's an exterior angle of the triangle because it makes a linear pair. Makes a straight angle if you like that term, all right? Becomes supplementary with an interior angle of that triangle. So in other words, angle 1, we'll call this angle 4. They're a linear pair, all right? They're a linear pair. Angle 1 is on the outside. It's joined like so. Angle 4 is on the inside, interior. Ha-ha. Now, that gives you the idea of where the exterior angle is. Now, Ernie did say something about what? How many? 6? All right, let's see if I draw this side out a little bit more. We're going to do it just right here. And look, look, look. I always say look, look, look a lot, don't I? Here, we'll call this number 5. Angle 5 is also an exterior angle to that angle 4. Now, you say, well, what about that guy? It's outside the triangle. It's a vertical angle to 4. It is not, I repeat, not an exterior angle of the triangle with the definition we've set up. In other words, we have to have the linear pair, the supplementary pair, with an angle inside the triangle. Which brings me to the next question. Okay, well, that's interior. That 4 is interior. You got it. So let's put another couple of numbers. How about 2 and 3? Just because I love numbers. It's a math show, right? We got to have numbers. Got to have numbers. All of a sudden, we've asked the word, what are the remote interior? What is that? And in this case, remote, in my opinion, means far away. When you use the remote to click me on or off, and hopefully you're clicking me on, okay, and keeping me on there, you're far away. You don't have to go out and punch the TV or figure out, it doesn't do that anymore, do they? That's the old type TV sets. It's all about remote control. Remote means you do it from far away place. You can only go so far away. Well, in this case, you can only go so far away, but let's look at angle 1. 2 and 3 are the 2 interior angles that are the furthest away. So that's why we call them the remote interior. You say, well, is it always going to be 2 and 3? If it's angle 1 or 5 out here, if it's these 2 angles, yes, those are the furthest away. But let's suppose I draw one more puppy in here. Oh, you knew that was going to happen. Here comes another one. How about it? Angle 6. My friends, angle 6 is it's an exterior angle of the triangle. But it's attached to 3. You see how this works? It's adjacent right there to 3. So that makes a linear pair, but now 2 and 4 become, yes, they become your remote interior angles. It's relative. It's a location, location, location. So if I drop down another line, because some of you think, I bet he's going to drop another line down. Well, of course I will. There we go. We've got another exterior angle. We'll call it angle 7. But it's still remote. It's still remote in terms of what? 2 and 4. Those are the remote interior angles, 2 and 4, based on angle 7 also. So there you go. And now you say, well, could you have done that? Yeah, I'm out of room up there at the top. But we could also do the same story at angle 2, all right? And then 3 and 4 would become the remote interior angles. So it depends on which angle are you picking. Now, you say, are you going to get to that theorem? I really plan to. I really do. All right, so let's move forward and see where this is going to take us. All right, we got it going here, guys. Thank you. Here is the deal. Oh, we've been waiting for the deal, haven't we? Let's see what it is. It says we're going to prove the measure of the exterior angle of a triangle and is equal to the sum of its remote interior angles. Once again, I pick an exterior angle. I'm going to call it 1. And I'm going to put 2 and 3 right there. It's equal to the sum. Now, that means we add those together. So be careful. I like the word sum. I really do. Just like I hate when I hear people say supplementary angles are 180 degrees. Supplementary angles are measures who add up to 180 degrees. A straight angle is 180 degrees. So terminology, be careful. That word sum, to the sum of its remote interior angles, is very, very important. So what we're going to try to prove here, we're going to prove, pretty straightforward, that the measure angle 1 should equal the measure of 2 plus the measure of 3. Now notice I put 1 out there as the exterior angle because I've seen times, oh my goodness, when we have people trying to say 2 plus 1 gives you 3, and then it gets very confusing. So it's all about position. It's all about the location here. So let's take a look at how we're going to prove this out. And remember, I said it's about Blockbuster. And you know what? We're going to probably see some situations where we'll have to wind up using some examples here. I know we're running close on time. So first of all, what you see is what you get. Angle 1 is an exterior angle. So where we're going to go here, we're going to bring in a 4th angle. Right there. Well, it's already there. We're just going to label it. And what I want us to notice here is how we're going to do this. First step is that the measure of angle 1 plus the measure of angle 4 is going to give us 180 degrees. Now we can start off and say those angles are supplementary. That's usually what we do. I'm going to combine again, shortening my time here. And we've got linear pairs that are supplementary. Remember, linear pairs are 1 and 4. All right, they're joined together, they're adjacent. They formed off a straight angle. They add up to 180 degrees. The next thing we're also going to notice, remember I said it's about Son of Blockbuster? Blockbuster theorem says we add the angles of a triangle to get what? 180 degrees. We're going to do exactly that. So we're going to pick up angle 2 plus angle 3 plus angle 4, and that's going to equal 180 degrees. And I'm going to use, just for you teachers who say, well, my book never used the word Blockbuster. So we'll call that the Triangle Sum Theorem, okay? Blockbuster, Blockbuster, I love Blockbuster. All right, now here we go. We got, that's not Sam, that's Sum Theorem, and we're good. Now, notice something about these. They both equal 180. So here comes the long stretched out piece. Boy, you know, I just went out the whole pocket there, didn't I? So let's take a look at what I mean by long. Both these are equal to 180, therefore they equal each other. You can call it substitution because you're basically replacing 180 with this whole mess. Or I prefer the nice little word called transitive. So I'm going to say here, measure angle 1 plus measure angle 4 equals the measure of 2, see if I can put that in there, plus measure 3 plus the measure of 4, because they both equal each other, because they're both equal to 180, right? Everybody agree? Of course you do. That's why you're watching the show. Now, put a transitive on there, and for those you like substitution, put a substitution on there too. That'll be fine. That'll be fine. Now, remember what are we trying to get to? This one, we're really home free, my friends. Because now what are we trying to get to? We're trying to get to 1, 2, and 3. Notice I have a 4 on both sides. 4 on both sides. Which means if I get rid of it on one side, in other words, if I subtract it off, means I'm going to have to subtract it off the other side, and we'll say goodbye to those by subtraction, property of equality. You've heard me say that on my shows many times. So here we go. We got angle 1 equaling to what? 2 plus 3. And that, once again, we said was by what? The subtraction property of equality. That's why it works. Son of Blockbuster's got a little bit of Blockbuster in him. No, you have to have Blockbuster to get to the answer there. We call it a theorem. Some folks actually call it a corollary. Next lesson, we're going to look at some corollaries of the Blockbuster gang, all right? and you're getting a little taste of it. But just a little point here real quick. Let's suppose I told you that angle 2 was, how about it, 40 degrees. Angle 3 up here was 60. Based on what we just picked up, 40, 60 is 100. There's your angle, angle 1, right there, 100 degrees. And by the way, that leaves angle 4 at, everybody with it? Go, go, go. 80 degrees. 180, linear pair. 180 in a triangle. Exterior angle business, 40 plus 60 gives you 100. It works. And that's how we get the degrees. We'll put some X's on that the next time, all right, or another lesson, and we'll have some fun with that, all right? Little algebra applications there. Hey, thanks for tuning in today. Thank you for hanging out with us. A little bit of test prep here. You've got to understand the whys before you can do it. We'll see you again next time.